Alright, so let me start. My today's talk is performance comparison of machine learning based sentiment polarity mining from CodeMix Twitter data. As a brief introduction, my name is Yaya Heryadi. I am a faculty member and researcher from Binus University. Before I continue, let me explain some basic concept in this study. First of all is sentiment polarity mining, also known as sentiment analysis. According to Nasukawa and Yi in 2003, sentiment analysis is a process to extract polarity of positive or negative sentiments on a subject being studied in a text or document. The second concept is code-mixed text. According to Poplak and Heller, code-mixed text is alteration of two languages within a single discourse, sentence, or constituent. Myers and Scotton in 1993 also defined code mix as the use of word, phrases, or sentence from one language into speech or writing in another languages, and it may contain misspelling word or non-standard grammatical structures. Next concept in machine learning algorithms, according to Samuel in 1959, machine learning is a branch of computer science that studies algorithm design methods which are capable of learning or adapting to data patterns without being explicitly programmed. In 1997, Tom Michel defined machine learning as a collection of algorithms that learn from experience E with respect to some class of text T and performance measured by P if each performance of at tasks in T as measured by P improves with experience E. Code-mixed text sentiment analysis is very important in the past decades because wide availability of code-mixed data, for example, social media data. According to Villares, Alonso, and Gomez Rodriguez in 2015, analyzing code-mixed text sentiment cannot be implemented with monolingual analysis method. This problem or these issues because of, first of all, according to Pravalika et al. In 2017, in code-mixed text, there are some inconsistency in writing of lexicons and the use of grammatical structures. Chowdhury et al. In 27 also concluded that in code-mixed text, there are some change in the spelling of a word, the use of transliterated words from other languages, or the use of sentence structures that do not comply with language's grammar. And finally, Sinks and Lefevre, the use of non-standard word or phrases, use of abbreviated word or phrases, misspelling, use of emojis or emoticon, or use of grammar construct contribute to the challenging analysis when code-mixed text is used as input. Sentiment analysis problem can be formulated as follows, according to Valada, Oliveira, Brooks, and Burger. Sentiment analysis text is typically classification problem. So given a label data set, X, a pair of X and Y, X is a text representation and Y is label, okay, or polarity of sentiment categories of the text. And by using the machine learning method, the sentiment categories can be formulated as a mapping of a function, call it G, that map X to Y. And the problem is how to estimate this a function using machine learning models whose parameters are approximated from optimization algorithms that minimize objective function. In this research method, I use this framework. So first of all, code of mixed data is pre-processed to convert all characters to lowercase, converting slang word, converting numbers, removing punctuation, special symbols, stop word, and white spaces. And finally, if it is applicable, also we remove URL address. Now the data that has been pre-processed then split it randomly into training data set and testing data set. Each of these partition has their own label. And then training data set and testing data set are translated into English word using pre-trained machine translation models to obtain equivalent training data set as well as equivalent testing data set. Now, the training data set is then used to build sentence representation or sentence embedding. Then the result will be used as input for training data set for machine learning models. In this study, we explore support vector machine, logistic regression, naive Bayes, KNN, random forest, and gradient boosting trees model. Having been trained, and then this model is tested using testing data set um, uh, from where we can obtain performance metric to compare performance of each trained models. In this study, we use a collection of relevant code mix sample of text from Twitter social data with bilingual code mix languages of Bahasa Indonesia and East Java dialect of Javanese languages. The total sample is about 1,160, comprises of 530 or 45.7% with positive label samples. And then the rest will be the labels and negative sample. The labeling process for input dataset was implemented by an expert who speaks both Bahasa Indonesia and Javanese languages. And this input is then randomly split into training dataset amounting 80% and testing dataset amounting 20%. The training result we obtain from experimentations that among 6 machine learning models, each of which was measured by average accuracy, precision, and AUC, or area under the curve, or IUC, logistic regression seems to excel from the rest of the models that we explore in this study, in which average accuracy of logistic regression is 0.98, while SVM is 0.97. And then similarly in precision, okay, and as you might look at the loss curve here, ROC curve, it seems that the logistic regressions is show the better performance. So some factors contributed to the sentiment analysis result. From our experiments, we found that the culture is very dominant because in this study we use translated of many expressions in East Java dialect of Javanese languages, which are interpreted as negative sentiment by the pre-trained machine translation model. Okay. But however, for East Java dialect of Javanese language speaker, it is common expression. The second reason contributed to false positive and false negative is accuracy of machine translation model when we gave the local dialect of Javanese languages. So it appears that Google-based machine translation model is trained using standard Javanese languages, okay, rather than dialect of Javanese languages. So as conclusion, sentiment analysis model to extract sentiment polarity from code mixed text accurately is important to extract opinion from large volume of text in bilingual or multilingual text. And the popularity of Twitter social media recently in many countries, including Indonesia, has provided a tremendous amount of data for sentiment analysis, especially to address code mixed text in Bahasa Indonesia and local languages such as Javanese languages. From the experiments, we found that logistic regression can achieve the best performance in compared to the other models. Okay, and for the next study, we plan to explore to develop more robust sentiment analysis for code mixed text involving Bahasa Indonesia and some local languages. Okay, will be used as input to the next study. In this opportunity, I would like to thank the Esan from Prince of Songkhla University, Thailand, for providing access to grid computer server. And also, this study is funded partially by Binus University under international research grant. So this is my reference, and thank you.